Good day, students. Today, we are going to talk about power and radical functions. Now, we should probably define what a power function is. Power function is any function of the form f of x is equal to a times x to the power of n, where a is not equal to 0 and n is not equal to 0. And a and n are constant real numbers, okay, that aren't 0. Now, what does that mean for you? Well, so x to the first, x to the second, x to the third, anything times that's a number, um, makes it a power function. Okay, simple as that. And we're going to be dealing with a lot of different ones and how we can possibly graph them without having to use our graphing calculator or put much thought to it. Monomial function is any function that can be written as f of x equal to a, or f of x equal to a times x to the power of n, where n doesn't equal 0 and a doesn't equal 0. Okay, because that just means everything will just go to 0. Um, and of course, a and n are constant real numbers. So if it's just simply something times x to the power of something, monomial function. That's nothing else other than that. It's a monomial function. Now, this bottom part of your first page of guide notes is going to be used as a cheat sheet, kind of what do you do when certain functions are certain things, right? So we have a monomial power function of x equals a times x to the power of n. So what happens when your exponent is even and your a value is positive? Well, it's going to be all of these things. I need to print right there. Domain is all real numbers, negative infinity to infinity, and all this other information down here. Okay, so this is only when n is even and a is positive, and then over here when n is even and a is negative. As you can see, it's facing down, right? Your parabola or whatever U-shaped graph is, because it could also be x to the fourth, 6, etc. And the a value is negative, it'll be facing down if a is negative. Okay, so make sure you jot all this lovely information down. I would recommend you pause it right now and jot it down. Now we're going to do when n is odd instead of even, okay? So once again, pause the video, jot it down, all this lovely information. Similar stories, except for now, domain range are both all real numbers, negative infinity to infinity. And as you can see, in the case of a being positive, it never decreases. Never. And it's always increasing, as opposed to when n is odd and a is negative, it's never increasing and always decreasing. All right, time for two examples. So we got y equals 3x to the 6, and f of x equals negative 2/3 x to the 5th. And I made a nice little table for us. And based on the table, I was graphing it. Now, obviously, I can't plot 2, 192, so I just made sure that after I hit 1, 3, it just shoots up. Same thing with negative 1, 3, shoots up. I didn't draw them best, but these are going to go poof, quick. And then we got this graph right here. There's a 5th power, so and a is negative, so it's going to be starting up high here and then ending down low here. And then here's all the wonderful information that I could ask you about these graphs. Hopefully you'd be able to answer them based off of all the wonderful information from the first page, right? So I recommend you pause, write this down, and maybe look at the graphs and compare it to what you just wrote right here. And hopefully that should make some connections, especially after chapter 1. All right, now time for negative exponents. So we got f of x equals negative 1/2 times x in negative 4th. Keep in mind, another way to write negative exponents is you put them in the denominator, make them positive. Isn't that fancy, huh? Yeah. So it's like we're graphing these functions right here. So let's talk about the domain, range, and all that good stuff. I recommend pausing this briefly to write down all the information from the negative exponents portion. So the domain's everything but 0, right? Because look, you have x to the fourth in the denominator, so x can't be 0. Also, range 0 to infinity. Why? Because look, even power. Even power, right? Yeah. No, I just realized that I was looking at the wrong answers to this. I'm sorry. So range is actually because this is negative, and x is going to always be positive. So let me fix that up. All right, adjusted the increasing, decreasing, and the range for us. So range is negative infinity to 0 because we're going to be living down here in the third and fourth quadrants here. Discontinuous at x equal to 0. What type of discontinuity? It's going to be infinite. Okay, so it's going to be doing one of these. So if I put, let's say I put 1 in this function, your output's going to be negative 1. If I put negative 1 in this function, my output's also going to be negative 1 half. So right there, and then a point right there. And then as I keep increasing, it's going to keep hugging the x-axis and then swoop down here. How about that? Looks good, right? And then time for our other one. And here's this information. Now, for the negative 1 half x to the negative fourth, I forgot to mention the end behavior as x goes to negative infinity of f of x is also 0. I ran out of space here, but I had space here, so I was able to write for both approaching 0. This function is always decreasing. All right, it's going to be a graph that looks like this. Well, first let's plot a point or two. So if I plot 1 in for x, output's going to be 4. If I plot negative 1, it'll be negative 4. And it will end up doing something like this. So at no point is the output the output is increasing, not once. Okay, it's always getting smaller. See, smaller, smaller, smaller. And when we go back up here, smaller, smaller, smaller. So it's always decreasing. Rational exponents rule. Jot this definition down. I'm going to paraphrase a little bit and put some words to this. So if the denominator of a rational exponent is even, say 2, your denominator is like saying, if it's 2, it's like saying the square root. If it was 4, it's like saying the fourth root, etc., etc. So if it's even, remember, we can't find the square root of a negative number, or a fourth root of a negative number, right? So that's what all this is saying, is that if n is even, then the domain must be non-negative values. All right, so got two examples here. So domain for this, hopefully you pick out, the denominator is even, so therefore it can't be negative. So domain has to be from 0 to infinity, which will also be your range. Range, so let me draw. Range 0 to infinity, and it is including 0. You can find a square root of 0, fourth root of 0, 0. What else? So you have intercept at 0, 0. It is always increasing, right? Because once again, that can't be negative. Yeah, or that can't be negative, and 2 is positive, so therefore it's always going to be increasing. Let's put in 1, for example. Fourth root of 1 is 1. 1 to the third power is 1, so 1 times 2 is 2. We have value there. Fourth root of, let's pick another number. Let's say we have the next even fourth root is 16, okay? Because the fourth root of 16 is 2. And then 2 to the third is 8. 8 times 2 is also 16. So it's going to be way out there. So what's happening? It's going to slowly increase. If you picked up values like 3 and put in your calculator 4, it's just going to do a kind of a little hook thing. Okay, because remember how your square root function, now do not write this down, but your square root function did some one of these. Yeah, so it's going to do something similar, but take slower because of that third power. Okay, now let's go to the next one. You see this next one, your denominator is odd, so therefore you're going to have negative values, or you could have negative values. So your domain is going to be all reals. And what about your range? Your range as well is going to be all reals. Let's put some values in. So once again, 0 is going to be your intercept. Okay, nothing moved. Third root of 1 is 1. And then to the fifth power is 5. And then, or excuse me, it's still going to be 1. And 1 times 10 is going to be 10. And then if we put negative 1 in, third root of negative 1 is negative 1. Negative 1 to the fifth is negative 1 times 10 is negative 10. Now, what's going to happen beyond here? Well, it's going to tail off a little bit and not increase as much. If you picked another value, a perfect third root, say 2, or 8 rather. I'm sorry, 8 would be a better answer for that. You're going to get a big number in 320. So let's pick something easier. If we did 2, for example, 2 to the fifth is what? 32. Third root of 32 is, well, when you put 2 in, you get something a little over 30. Okay, so it's going to start slowly. Now, writing this exponential to radical form might help you. So if whatever is on a numerator of your exponential form, that stays with your base x. And then what's on your denominator, you put as your index for your radical. Okay. And then down below here, anytime we have a radical, here is our rules. I'm able to copy it down. As I'm doing that, I'm going to give you a brief graph of the even function. Will typically look like that in some way. Odd would look something like this because you're including negative values. You can find the third, fifth, seventh root, etc., of a negative number. So go ahead, pause, copy this down. So what I'd like you to do on your own, find all this lovely information. X and Y intercept, domain, range, end behavior, continuity, increasing, decreasing for these two functions and graph the function. Okay, see how you do on your own. Okay, I believe in you. And we'll go over it together in class. So let's solve radical equations together. First step you always do with solving radical equations is get the radical alone. So I'm going to subtract 3 to get it alone. Next, we can square both sides, okay? Now be careful. A lot of people want to distribute a squared on the left side. You have to FOIL. 3x minus 3 times 3x minus 3. So the squared and square root cancels out over here. That's why we squared. And then when we fill it out, we get 9x squared minus 18x plus 18. So what do you think we do next? Yeah, let's move everything on one side. It's much easier to move the stuff on the right to the left. If you did the other way around, it will work, but you're doing more work, unfortunately. After we subtract the 18x and add the 18 to the other side, we're going to get 9x squared minus 36x plus 36. I just realized something. Oops, negative 3 times negative 3 is 9, not 18. Whoops. There, should actually be 27 instead of 36. Now, factor. What do you notice here to make our life easier? You have a GCF, friends. Let's divide by 9. X squared minus 4x plus 3 equals 0. And factor that, you're going to get x minus 3 and x minus 1 equals 0. X equals 1 and 3. Now I'm out of space here. You solved it. We did it. Hooray! But what you got to do is check to make sure these work. So if you plug in one of these function and 3 of this function. Does it still work? And absolutely it does. Okay, sometimes it won't, so you have to check. Okay, common things you might see is that two sides don't equal each other, or the value you solve for makes your square root negative, and that's a no-no. Okay, but in this case, if you plug them back in, left side will equal the right side for both of them. So your solution is in fact 1 and 3. Let's try this other one. Once again, what's our rule? We gotta get the radical alone. So let's subtract 3, subtract 3. Third root of 4x plus 8 equals 4. So how are you going to get rid of that? Whatever the index is, that's going to be your power. So power of 3 to both sides. It get you 64 equals 4x plus 8. That's a simple algebra problem. Would you like? We like that. Nice. So we get 56 equals 4x. Divide by 4, get a value of x equal to what? 14. And if you plug it back in, it does work. So dude, please check your answers. I know it takes a little bit of time, but they do become wrong sometimes. If you are in regular algebra, you're done. Don't you see this problem? Have a nice day. If you're in honors, stick with us. We'll see this problem. This will take a minute, a good minute, okay? So, even though I have two different radicals here, we got to go straight to squaring it, okay? Unfortunately. We have radicals on both sides and you're adding or subtracting a number. You got to do this, okay? So you're going to get this x plus 7 on the left, and then you got to FOIL this right side, okay? When you FOIL it, you're going to get 9 plus 6 root 2 minus x plus 2 minus x. All right, now we can put all the radical on one side and everything else on the other. Okay, I'm going to do some like terms to make our lives a little easier. We're going to have 11 plus 6 root 2 minus x equals x plus 7. Let's add x. Add x. Subtract 11. Subtract 11. What you're going to get? You're going to get 2x minus 4 equals 6 root 2 minus x. Let's divide by 6. Or if you don't want to divide by 6 yet, and you know what, I'm not feeling it. Let's not divide by 6 yet. Instead, let's just go straight to squaring. Square 4x squared minus 16x plus 16 equals 36 parenthesis 2 minus x. So I can divide by 36, which is going to get us not fun fractions, sadly. So whenever, well, not terrible fractions, but I want to be able to factor right away. So get 1 over 9 x squared because 4 over 36 reduces to 1 over 9. 16 over 36 reduces to 4 over 9. And then 16 over 36 reduces to 4 over 9 as well. Equals 2 minus x. Let's subtract 2 and add the x. Common fractions, people. Let's do we plus 5 over 9x minus 14 over 9 equals 0. Let's make our lives easier because luckily it's all over 9, so we just multiply everything by 9 and we get nicer numbers. Yes! Let's go. See how much nicer that is? Because 0 times anything is 0, so now we can actually factor this. Factors of negative 14 add up to positive 5 would be x plus 7 and x minus 2. So your answer is going to be 2 and negative 7, but don't forget what we got to do. We got to check, okay? So let's check negative 7. So I put negative 7 plus 7. I'll mark this check. We use different color now. Square root of that equals 3 plus root 2 minus a negative 7. What do we get? That becomes root 9, which is 3. 3 It's 3 on the right, and then we get rid of 0, which is 0. 0 does not equal 6, folks. So therefore, the answer is only x equal to 2. We will call negative 7 an extraneous solution. Extraneous solution. Yes. So negative 7 does not work, but 2 does. If you were to check 2, it does. I appreciate you watching through this, and we'll see you in class. Bye-bye now.